Found widespread in the island of Puerto Rico is the Eleuthodactylus coqui, or simply the coqui frog. This frog displays a wide variety of colour and pattern polymorphisms, multiple phenotypes, in a single interbreeding population. For most frogs, including the coqui frog, the genetic basis of this variation is unknown. I'm Darci, and I'm presenting aspects of the research done by Eric O'Neill and Karen Beard, published in the Journal of Hereditary, titled Genetic Basis of Colour Pattern Polymorphisms in the Coqui Frog. O'Neill and Beard's objective was to determine the mode of inheritance, including the number of loci, number of alleles, and the dominance hierarchy for various patterns. O'Neill and Beard collected the coqui frog from 4 different populations in Puerto Rico and housed them in mixed pairs in identical terrarium habitats. The adults were scored for a stripe pattern and individually marked using a standard toe clipping method. The resultant eggs were collected and the hatchlings scored for a pattern 1 week and 1 month after their hatching date. O'Neill and Beard categorized the coqui frog polymorphism as follows: interocular bar, or B, narrow mid-dorsal stripe, or N, wide mid-dorsal stripe, or W, dorsolateral stripes, or L, and unstriped, or U. O'Neill and Beard organized their adult breeding pairs to determine the hierarchy between the polymorphisms. Their breeding pairs produced 71 clutches, providing 1,519 offspring from 11 different cross types. In this abbreviated results table, you can see the parental phenotypes, followed by the phenotype of their offspring. This is followed by the parental genotype, the dominance hierarchy, the expected ratio, and the observed ratio in the resulted hatchling. O'Neill and Beard's results suggest that the dorsal stripe pattern variation in the coqui frog is genetically determined and likely to be the result of a single autosomal locus they named stripes. They also suggest there are 4 codominant alleles responsible for the various stripe patterns and 1 universally recessive allele responsible for the unstriped pattern. In natural populations of the coqui frog, striped frogs are less common compared with the unstriped frog. This is an inverse relationship between the dominance hierarchy and the phenotype more commonly found within the natural population. This can be explained by some models of frequency-dependent selection, but whether it is responsible for maintaining the striped polymorphisms in the coqui frog is unknown and could be an area of further study. O'Neill and Beard also suggest that this polymorphism may be useful for studying adaptive and non-adaptive processes for maintaining genetic variation in native and introduced populations.